10 seconds, and then his parachute opens out. Now he descends with a net retardation of 2.5 meter per second square. If he bails out of the plane at a height, and g equal to his velocity on reaching the ground will be. What is the overall problem? Suppose if this is the ground, so somewhere the person is going to okay, there's a plane. From here, he will falls freely. Okay, the person, what will happen here? He will fall freely. For what time? For 10 seconds. How some imagination like this is very important. Huh? See, writing equations, okay, but we must have a basic thing like, okay, we are discussing a problem of this situation like this. This is a ground. So in 10 seconds, he will fall freely. After that, he will open the parachute. Now it descends with net retardation. So now what is the state of him? And he is going to descend. Let me draw it. He will hold like this. Okay, now he's going to descend. So his retardation will be how much? 2.45. This let me call acceleration A1G. This retardation 2.5 meter per second square. If he bails out of the plane at a height of this height at which he will bail out. His velocity on reaching the ground will be from here, there'll be retardation. Let me indicate that all the motion, this will be accelerated motion, free fall, or accelerated motion, I'll write it. This will be retarding motion. This will be a retarding motion. So with what speed? Okay, let me continue. I think there was some connectivity problem. So the person will come and strike along with the parachute. He'll come and strike the ground with a velocity. That velocity is what we have to find out. Here he will acquire a velocity v1. Okay, let's do one thing. What is v1 is equal to? We have so many other things. We have to plot even the graphs also. v1 is equal to 0 plus a1 t1. Okay, this will be 0. Okay, this will be a1 is how much? 10. t1 is 10. 100 meter per second. After falling freely for 10 seconds, he'll acquire this much of speed. Then afterwards, he is having a v1. Then he will descend certain height. No, here he will descend certain height. Can we calculate that height? H equal to a1 t1 square by 2. a1 is how much? 10 by 2. t1 is 10 square. 50 meter. You will descend 50 meter. The remaining height is going to decelerate. with a retardation 2.5. Okay, I think we can calculate. So what is the remaining H2 should be equal to? H1 plus H2 is 2495 meter. So therefore, what is H2? So this is 50 meter plus H2 equal to 2495. If you remove this 50, 45 will be there. Can we calculate now V2? V2 square, V1 square, 2 minus A2, H2. Minus 2.5, H2 is 2445. Oh, lengthy calculation. Let me simplify that here. Let me use calculator. 2 into 2.5 into 2445. 12,225. V2 is equal to, this will be 10,000. This will be 10,000. V1 is only 10, no? Okay, 100, this will be 10,000. This will minus of 12,225. This will become positive, this will be negative. Okay, somewhere we are ending up negative. Let me check the calculations once. This is 100, T1 square. Oh, yeah, some. I'm not that good in calculation. This will become 100. So this will end up, this will be somewhere I messed up here. So this should be 500 meter. Yeah. Now this will be 500. Because root negative should not be there. So 2495 minus 500. So this will become, H2 will be 2495 minus 500. Will be 1995. Nobody is there to assist me. 2495 minus 500, 1995. Okay, this 1995 will be a. Now 10,000. Okay, this will become 1995. 2 into 2.5 into 1995. 9975. I think V2 square will end up with 25. And V2 will be 5 meter per second. I think he can land safely, no? He has to strike, the person should strike the ground with a very less speed. He should reach the ground and he should strike the less speed. There's all the condition. So the what retardation, what height he should bail out. I think all there's a very lot of science is involved, not like just wearing parachute and you're going to jump. So not that easy, no? So all the calculations are involved, and the retardation, how much of retardation, looking at the height, where you build out, and the amount of retardation also can be controlled. This retardation also can be controlled by using these strings. So like we have to manage all this. If you bang with higher speed, it's a big problem. No, his muscles, his legs, all he may break out. So therefore, he has to strike with a less speed. He should land. Better saying he has to strike means he should land comfortably. So 5 meters is a very small speed. You will land comfortably onto the ground. Look at the overall. Okay, now we'll go for some graphs. Huh? This will be very interesting. What about the various graphs? First, it will fall. First, the motion will check it. First, what is the motion? It will be accelerated motion. The velocity will increase. Then afterwards, the velocity start decreasing. And it not become zero, you see this. So there's a maximum speed V1 and there's a final speed V2. Okay, this is the time 10 seconds. After what time you'll strike the ground, can we calculate? Yes, we can calculate that also. V2 equal to V1 minus V1 is how much? V1 100 minus 2.5 into T2. V2 we know 500 minus 2.5 T2. So we'll get the time taken for the person with parachute open and how much of time will descend here. So this will become 5/2 T2 equal to 95. 19, okay, this will be 19 into 2 will be 38 seconds. For 38 seconds, what will undergo retardation? So shall we write this? This will be how much? 48. See this, the problem is very beautiful problem. Okay, there's about the VT graph. What about the position versus time graph? First it'll accelerate. Then you will undergo retardation. And it will not come to rest. You land onto the ground with certain velocity. So therefore, this will be 10, 48. So what is the total? This will be 2495. And H1 we have calculated. So this will be 500. This is a position. S equal to 0, I'll define this one. Okay, you see all the graphs. No, it will not change direction of motion. Only it's like a first acceleration, then retardation. In every problem, you must end up all the possible graphs.